Hi there, I'm Matthew Haywood and I work at Blockstream, and in this tutorial we'll be using the Green Development Kit, GDK, through a Python wrapper to demonstrate how you can use GDK to build a green compatible wallet. Green wallets work with both Bitcoin and Liquid, and for this video we'll put the wallet in Liquid mode so we can see transactions confirmed during the course of the demo, as Liquid blocks are signed every minute. It's really easy to work back and forth between the two, Bitcoin and Liquid. There's just a few flags here and there that need changing, so I'll highlight the places where the code might differ if you are building a Bitcoin wallet. Green is easy to develop against, and by using the Green server's 2 of 2 security model, you can enforce two-factor authentication to protect your funds. You can also read about Green wallets and GDK on our website, blockstream.com/green, and the GDK reference documents and repository can be found online as well. That's the GDK repository. It tells you how to build the Python wrapper or a Java wrapper if you want. That requires Swig be installed. We'll be downloading the Python wheel though. And here's the GDK functions documentation, and then the JSON that those functions return is also documented online as well. So we'll be covering these steps when we set up the wallet. We'll be logging in with an existing 24-word mnemonic or generating a new mnemonic. We'll set a PIN for the wallet and log in with a PIN. We'll check and set the wallet's two-factor authentication 2FA status. We'll handle calls to methods that use 2FA, such as creating a spending transaction. We'll handle events in the Green notification queue, such as newly found blocks or changing network fees. And we'll get a new address and understand wallet-related transactions and how to view those using Green. The code I use for the example is based on the code on our docs site. The code is actually under the Blockstream AMP section, GDK Python example here, and as I said, this will enable you to transact assets over the Liquid network, but it will be very easy to change this to work with Bitcoin instead. Okay, so I'm using Linux, Ubuntu 19.1, and I've Python 3.7 installed with pip and virtual env. So let's create a working folder for the demo. Then move into the folder. So I'll be using a virtual environment for this, but you don't have to, of course. So I'll create an environment now and activate it. Now that's done, I'll activate the environment. Okay, now you'll need to download the tutorial code, which is from our docs website here in the background, docs.blockstream.com/amp/gdk-example.html, and that's got the code here that we're going to be running. Now I've already downloaded that in the background, and another thing that you'll need for the tutorial will be the actual GDK Python wheel, which you can get from here, github.com/blockstream/gdk/releases. So I've already downloaded those. Just a note here on the version of GDK that you use. You need to check what Python version you have first. Python 3.7.5. So it's this wheel I need to download. The 3.7, sorry, it's this one, the 3.737, not the 3.6. Okay, so as I've said, I've already downloaded those, so I'll just copy them over from where I've downloaded them. So that's the wheel copied over from where I downloaded it to, and then the actual demo. So you need to copy the Python demo code off of our docs website and paste that into a file. Call it what you like. I've called it gdk demo.py. Okay, so we've got those two files in there now, the Python wheel, GDK installation, and the actual demo code, and we've got the virtual environment folder in there as well. So if we try to run the code now, I'll actually just open that up in a editor. So here's the demo code that I've copied off of the website. If we try to run that, first of all, I'll just tell it to use the virtual environment. So if we run that, it will come up with an error saying that no module named green address. That's because we haven't actually installed that. Green address is the historic name for the package. So that's GDK basically. So we need to now install that wheel. We can use pip here with the virtual environment activated. So now if I just put a breakpoint in there to stop us getting too far and try running it again, it works that time. Okay, of course you can run the example from the command line. I won't because I want to be able to stop and walk through it, as it were. So there you go. So we've got the environment set up, virtual environment into which we've installed GDK, and we're ready to start actually looking through the code now. So the wheel installs a Python wrapper for GDK, and you can build the package yourself if you have Swig installed and you follow the instructions on the repository. And you can see there, you can also build a Java wrapper, again, follow the instructions there on the repository. Let's now look at the demo code itself. Okay, so now let's take a look at the actual code here. So in this demo Python file, what we've basically got further down here, we'll find a class called GDK wallet. Now what we're actually doing with this class is wrapping some of the GDK calls. So here we call in generate mnemonic, we'll be calling login, other functions, get balance and things like that. So this class maintains the state of our wallet, as it were, and the variables that we're going to be using, and it wraps the calls to GDK, and it does things, like when we're sending a transaction, it will handle the state transition if we've got two-factor authentication enabled. So every call to GDK is basically wrapped within that GDK wallet class, which we'll be calling from up here. So the first thing you'll need to do is initialize GDK. That's sort of standard. You only need to do that once per code run. And then here we've got a call called create new wallet. So we'll be creating a wallet, we'll be logging in, and then we'll be checking the balance of the wallet, and then we'll be doing other things later down here. We'll be checking the two-factor authorization, and we'll be also showing how to set a PIN and log in with a PIN. We'll also be getting the block height, so that uses GDK's notifications queue. Get new address, and we'll send some liquid Bitcoin to this address, and then we'll check the balance and get the wallet transactions to see that transaction confirm. And then later on we can send to an address. So back up here. So first of all, we got create new wallet. Now this accepts two parameters. One is to telling it whether to create with two-factor authorization enabled or not, and the other is mnemonic. So if you did want to, you could pass a mnemonic in here, 24 words spaced with one space, and GDK would use that to register the wallet with the green server. But we're going to leave that blank so we can actually generate a wallet here. So I'll just run the code and we'll hit that breakpoint. So I'll step into there, and we haven't passed the mnemonic in, so it's going to generate one. So it calls GDK, to generate a mnemonic, and here we go. Here's our 24-word mnemonic. It's just generated, and then it will create a session object here. Now, here we're passing in name liquid. If you leave that blank, it will connect to Bitcoin instead. We register the user, and then we'll log in. Now, just a note there on the use of the mnemonics. The mnemonic is never passed to the Green server. When you pass mnemonic to functions such as register user or login, the mnemonic is locally used by GDK to sign messages or transactions and derive keys and addresses. So for instance, in register user, GDK derives on the client side an XPub from the mnemonic. So that's never passed over the server or anything like that. And if you'll sign into the wallet, as we'll do when we come out of here, using the mnemonic, but you can also use a PIN, which we'll come back to in a moment. So we'll just step over that. So that would register the user, log in. Now create sub account. That's not needed if you're developing a Bitcoin wallet. We're actually creating a liquid wallet, and we're creating a Blockstream AMP sub account. Again, you don't need this for Bitcoin, and you don't actually need it if you're creating a liquid wallet, but this example is taken from the Blockstream AMP demo code. So this creates a sub account, provides a name and an account type. Now create with 2FA enabled, we've said no, so it won't do that. You can, the code's got examples of how to enable that or disable it later should you want to. Right, so we've got our mnemonic, print it out here, 24-word mnemonic. Down here you can see it in the debug terminal. Okay, so I've actually already got a mnemonic which I generated before, which we'll use now. Okay, so now we'll log in. This is doing similar to what we did when we created the wallet. Apart from this time, don't have to do the register user because that was done as part of the creation when I created that particular wallet. So we'll sign in again. You don't need to create. You don't need to pass liquid in here if you're using Bitcoin. This GDK for Bitcoin. We'll log in. We'll fetch the sub account. The sub account's only important for Blockstream AMP. So you can ignore this if you're not developing a wallet for Blockstream AMP. It basically loops through all the sub accounts, find the one that matches the correct sub account pointer that we created the wallet with, sets that. Now the green account ID is very useful for Blockstream AMP. It's how an investor is identified or a user is identified. But that's detailed. If you want to read about how to use GDK with Blockstream AMP, in particular, and what things like the green account ID do, refer you to the docs.blockstream website there. So now we're going to fetch block height. So this is interesting, as this is an example of how to process the notifications queue in Green. So new blocks are added to notifications queue as they're found. Notifications queue also contains the fees, required to confirm within 1 to 24 blocks as an array. So we'll get the notifications and we'll basically loop through them. So we have different event types. One event is the initial settings. We're not interested in that at the moment. Two-factor reset. I'll just keep going until here's one that's block. Okay, so the block height at the moment, of course, we haven't actually got a block height at the moment. But this is the first time we're querying the queue. So the first time you sign on and query the notifications queue, will always have the last block in there. So we're just storing what that is. The block height, this is liquid 1178327. Okay, so now that we've signed in, logged in, we can perform functions against the wallet. So here we're going to get the balance. That just simply calls the session, which is GDK session object, get balance. Now you'll see some of the functions we call resolve on, and other ones we will actually process the resolution, as it were, of the calls, method calls ourselves. Now, something like get balance, because it's not wrapped in two-factor authentication, we'll just call resolve, and we'll let the GDK code resolve the to and fro in between GDK and the server, and it'll just return the result of that, which is the balance. Later, we can look at the two-factor authentication wrapped calls, such as let's find it down here, transactions. So this will actually be resolved using this method here, GDK resolve, which handles the back and forward of authentication processing. We don't need to do that for balance. It's not covered by 2FA, so we can just resolve that call, which will return us our balance and print that out, which is actually 0 BTC. The other calls get current 2FA status, so this will return the, unsurprisingly, the current two-factor authentication, which we can get the two-factor config, print that out to the screen here, and I'll just show you what's in it. So it tells you what methods are available: email, SMS, phone, or Google Authenticator, which are enabled, none, and whether it's been confirmed. So confirmed as in, if you were to set email, it would then send you an email to authenticate that you do indeed control that email before it activates it. So we'll take a look at those in more detail later anyway. Okay, so block height we've already been through, and the current block height displayed there. Right, so now let's get a new address, and I'll actually then send some funds to the wallet, and we can see what happens there as it receives the funds. So we'll get a new address. Sub account, this section here, you don't need that if you're calling Bitcoin. And we just resolve this straight away. So I'm going to print the address information out there. So there's our address. So I'll just quickly send some funds to that. So I've just sent some funds using my Green mobile wallet. So we've got the new address. This is just to show that each time you call a new address, you get a new address, and important only really to the liquid side. The liquid side of it is the address pointer. So I'll just you can read about that on the doc site if you want to. So here we can get the balance for the wallet now. Print out. So we've got 1362 sats. That shows as BTC, but it's actually LBTC, liquid Bitcoin. And then we can get the wallet transactions. Now that will be unconfirmed at the moment. So if I just quickly step over this. I'll return out of this, and then transaction hash, confirmation status is unconfirmed. Block height, there is no block height at the moment. Type, it's an incoming, and it's got one input and two outputs. One will be change. So I'll stop that. I'll wait till it's confirmed on my phone. Skip over back to there. So when it's confirmed on my phone, I'll go in here and we'll actually look in a bit more detail, and the transaction will be confirmed then. So we'll step into this to start taking a look at this. I'll just highlight, I'll just explain the structure of this first, but it's important to remember that transactions are returned in the order of most recently seen transaction first, and it's possible for a transaction seen less recently to be unconfirmed while a more recent transaction is confirmed. This is perhaps less of an issue with Liquid, where the blocks are created on a minute-by-minute basis, but in something like Bitcoin, where the fees are very variable over time, it may well be that you've sent a transaction more recently than an older one, and the more recent one is confirmed, but the older one hasn't. So you probably do need to, or you do need to loop through all the transactions. If you're keeping a record of these somewhere within your application, transactions incoming or outgoing that have been confirmed or not, don't just stop at the last one that was confirmed, because there may be previous transactions which have not yet been confirmed. So we've got a confirmation there according to my phone. So we'll get the current block height, we've already looked through the fetch block height. Remember, it went through the notifications queue. So the current block height is 11783337. Now you can override the default number of transactions returned. I'm just showing that by way of example here. So count 10. The default is 30. So when you call this the session get transaction GDK session get transactions, you can tell it where to start and how many to return. So you can page through them effectively. You can return a large number in one go if you want to, but you can page through them. I'm just using 10 as an example here. And a note again, sub account, you don't need to provide that if you're just doing this with Bitcoin. So we'll return a list of all the transactions. There's one transaction here. And oops. There's one transaction here. We'll pick the details out of it as we go through. So the confirmation status, we'll start off by saying that it's unconfirmed, but then we'll check the block height. And the block height is the transaction block height. So that was a block it was confirmed in, which ends in 8337. And up here, if you remember, we actually went and got the latest block, which is this block. So it actually confirmed in the block that just passed. So the block height will be greater than 0, of course, which is we just initialized it as. The depth from tip is 0, so that means it's confirmed. Now here, because we're using liquid, we class one block as confirmed and 2 as final, and we can't have reorgs that are longer than that. So 2 confirmations in liquid is definitely final. Obviously, if you're doing this in Bitcoin, you may want to write your own confirmation status based on how deep the confirmation is. But for the purpose of this liquid example, we now say that that's confirmed. So we'll fill that in. We're actually just building up here a list of the transactions. We'll return that and we'll print it out to the bottom here. Just expand that slightly. So there we go. It's incoming type 1 confirmed, and our balance will now show. Well, our balance had shown it because the balance included unconfirmed transactions. You can make it return just confirmed. I'm going to stop that and get right back to that point. I can see on my phone that another couple of blocks has already been found. So we'll go back and do this again. So the chain block height is 11783339. You can step through this again. And now it's unconfirmed. We'll start off saying it's unconfirmed. Oops. Then we'll check the block height. And the depth from tip now is 2. So it's 2 down in the chain. So we can say that the status is final. So we've got a final confirmed transaction there. So now that we've got some Bitcoin in here, I can actually send it to another address, and we can look at enabling 2FA as well. Let me just clear some breakpoints here. So further up here, I did mention 2FA. So I can enable 2FA for the wallet here. I'll step into that so we can see what's going on. So email, there are other options, SMS, phone, and Google Auth, but Haywood always just uses email. Okay, so it's asking me down here, asking me for the email. Okay, next now asking me for the authentication code that I received to that email. So I'll enter the code which I received over email to prove that I have control of that email account. Okay, so 2-factor authentication is now enabled. I'll just stop that and we'll go back up here and where we queried the 2FA status here. So now when we print that out, Yeah, we can see that the any enabled true, and then it provides details of the one that is enabled here, email, confirm true, my email address, and the fact that it's enabled, and I've confirmed it. So any calls which require wrapping in two-factor authentication, when I go to my email address. So what we'll actually do is we'll just put a breakpoint there, and I'll send 100 of the BTC to the destination address. So, and then we'll be able to see it step through the authentication process there. So I'll just generate an address. Outside of this, I'm doing this in my Green wallet on my mobile. So I'd emailed myself or sent myself back an address from my Green mobile. So now we can run up to that point. You know 2FA is enabled. So I'm going to send 100 sats back. The type BTC. You won't need to fill in the asset ID if you're doing this with Bitcoin. Step into that. So send to address, the amount in sats, it always works in sats. The asset ID, not required if you're implementing this on Bitcoin because it is only one asset, and the address where it's going to. Again, the details here, you don't need the sub account pointer if you're doing this with Bitcoin, or the asset tag. So this is what I was talking about, resolving the calls to GDK. We've wrapped them here in something, in a method called GDK resolve, which you can copy from the demo. It basically allows you to enter details in to the command line into the terminal to progress the steps through to completion. So the state at this point is it will call. So it's called the method. It's done, but then when we actually send the transaction, should have put a breakpoint in there, my apologies. It's asking us to enter the authentication code. Try and put a breakpoint in now in that resolution there. So I'll enter the code that I received to my email, which is 599215. And the transaction's been sent. Authentication succeeded. I'll do that again, and I'll actually step through the. There we see the transaction. I'll do that again. I'll actually step through the process now that I've got a breakpoint in. We'll step through the resolution process, and we can see it move through the different states until it's completed. So I've just waited for that transaction to confirm so that the change is sent back to my wallet. I did mention above that you could disable the, or you could rather turn off, as it were, the 2FA on a wallet. You basically call this function here and just pass false in. That would then send you an authentication code, authorization code, which you then enter to disable your current 2FA method. But we'll leave it on because that's what we want to see. Here. So we'll get back to the point that we're about to do this send. Okay, so if we check in here, our balance should have adjusted because we sent the LBTC sats out to the other wallet address. We also paid some fees, a small amount of fees on Liquid in LBTC sats. So send it to the same amount, same address. Okay, so create the transaction. That doesn't require any interaction. Basically, the state is just calling. It gets called, and it's done. There's no authentication required. Authentication succeeded or not required in that case. Same. So then we've got signing the transaction, which will call the method. And that's also done. So that's been signed here. Now we send the transaction, and this will get signed the other end using Green's 2 of 2. So we've signed the transaction, the wallet has, completing 1 of 2, and then we ask Green to countersign. Before Green countersigns, it's going to send us the authorization request, which is what we'll see now. So we'll call, request the code rather. Code requested via email. And then it will resolve the code. So here we've just got entering it into the terminal, but obviously if you had an application, you'd be asking the user through whatever interface you had there. So I will have received that code via email, which I will now enter in. So this is saying to Green, yep, it was me who signed and sent you that, and I do authorize you to countersign and broadcast the transaction. And calls the appropriate method and comes back as done. And I can see in my mobile wallet I've got here, I can see it's just pinged up saying that I've just received 100 LBTC sats. And there's a transaction ID. Now, if I take that transaction ID and I go to blockstream.info, which is where our Liquid Block Explorer lives, I can paste the transaction ID in there, take a look at it as it's seen on the public Liquid blockchain. You can see it's unconfirmed. It will confirm in one block. Transaction fees are always unblinded, but here you'll notice that the transaction was confidential. So there's no way of seeing what amount was sent, only the fees that were sent. We can go and look at a particular address and see, if we look in there, transaction count, we've no idea the actual values because these are all confidential. So if I expand the details, you can't see the amount that was sent. Indeed, you can't see the asset that was sent. This is one of the benefits of using Liquid, is that all transactions are covered by confidential transactions. So anybody looking at it, apart from the sender and receiver, won't know the amount or indeed the asset being sent. So that sort of concludes the main functions that I wanted to cover there. As I said, this code is on docs.blockstream.com, and it's under the Blockstream AMP section, Python example here. Now you can write your own wallet using GDK. This is just an example in Python. There is also something called the Green client, which Blockstream was linked to from this site, which wraps all of the calls to GDK purely through the command line. I haven't looked at the pin sign-in, but I will explain how it works here. Essentially, with pin sign-in, you'd log in with the mnemonic first of all, then you'd set the pin, don't use that one. What setting the pin actually does is it encrypts the data that's stored locally. It encrypts and stores the mnemonic locally. So when you log in with PIN, you have the mnemonic encrypted on your device. If you get the PIN right, the server will give you the key to decrypt the mnemonic, so you don't have to input the whole mnemonic each time. If you get the PIN wrong 3 times, the server will delete the key and you must use a mnemonic to sign in. So it's a feature of convenience, really, entering a PIN. So I could have signed in with a mnemonic, set the PIN, and then log in with the PIN instead of logging in with the mnemonic each time. But if you want to develop this, the example here, although it's under the Blockstream AMP section, there's only a few things you need to change to get this to run with Bitcoin. The overview up here tells you how to install it, which we covered earlier. But it will just be things like you don't need the sub account and you don't need to specify Liquid when you're initializing or when you're creating the session object. So you don't need to do that bit. That covers Blockstream GDK, calling it from Python. As I said, you can find all the documentation, the example that I've just been through on docs.blockstream. We've got read the docs site for GDK, the data returned and the actual functions. And here on the actual repository for GDK, you can build your own Java and Python wrappers if you want to, if you have Swig installed. Otherwise, you can install the wheel like I did. Thank you very much for your time.